Hello, this is Lake, creator of the Overdrive Off-axis ducted fan. Now, ducted fans are fans which are enclosed in duct or shroud, and they're mostly used in drones or unmanned aircraft systems. So far, plenty of innovations has been made on the fan, the stator, then the shell, etc. However, the effect of the spinning motor on the duct fan performance has been ignored. Essentially, for a conventional motor layout in a ducted fan, the spinning motor increases the swirl in the slipstream of the flow and hereby reduces the thrust and hence the overall efficiency. The very purpose of this innovation is to reduce this effect of the spinning motor on the entire duct fan performance, and hence I came up with the off-axis ducted fan. In this off-axis ducted fan, the motor is placed away from the wet area of the duct, and hence it reduces the swirl and the overall thrust and efficiency thereby is increased. You can see that for a conventional motor layout on an on-axis configuration, the swirl number, which is the ratio of the angular to the axial momentum, is 3.5. But for my design, the swirl number is much low and it is 2.75. Here is where the strategic design of the stator as well as the off-axis configuration of the motor comes into effect. The main constraint for this design is the mechanical transmission. The high-speed mechanical transmission has to be in a way that it can handle RPM as high as 25,000 on the fan. And depending on the number of blades on the fan and the required torque, the gear ratio can be altered. Overdrive transmission here means that the motor spins much slower than the fan itself. So far, we have done wind tunnel experiment and we have got overwhelming results.